Hi, this is Mrs. Moret with a review of finding a missing angle in a right triangle using sine, cosine, or tangent. The angle that we're looking at for this triangle here is down here on the left with a question mark, but maybe we should name it theta. So the measurement of theta can be found using these two sides that we know. So in reference to this angle here, the side marked with an 8 is the opposite leg, and the side marked with a 20 is the adjacent leg. And so looking at our list of trig ratios, it looks like the ratio that uses opposite and adjacent legs is tangent. So we're going to be using tangent to solve for theta. So what I know so far is that the tangent of theta is equal to 8 over 20, 8/20. So the tangent of theta is equal to 8/20. Well, I need to know theta itself, and so if I know what its tangent is equal to 8/20, I can use a function called inverse tangent. So inverse tangent, um, we note that using that notation, and then we can also find the inverse tangent of this. So this crosses out, and we have theta itself is equal to the inverse tangent of 8/20. If you're using a graphing calculator or most scientific calculators, to access this inverse tangent function, you would type second, then tangent button, and then 8 divided by 20. Using Desmos, after we get into the program, and then remember that you need to change the mode to degrees instead of radians, and that's on the tool button. So to find inverse tangent, it's actually in this menu under functions, and you can see sine, cosine, tangent, and then next to each one is the inverse. So we need the inverse tangent, and then I'll just type in 8 divided by 20, and it says about 21.8. So that tells me that that angle theta is about 21.8 degrees. And on the second example, again, we can call this angle theta down here that we're looking for. And the sides that we know this time are the opposite, which is marked with a 14. And the side with the 24 is the hypotenuse because it is opposite of the right angle. And so the ratio that uses opposite and hypotenuse is the sine ratio. So what I know is that the sine of theta is equal to 14/24. And so again, we're trying to find theta. And so what we need to do that is use the inverse sign. So theta is equal to the inverse sine of 14/24. And so using the Desmos calculator, I'm going to find the inverse sine under the functions menu. It's right here. and 14/24. And so I see about 35.69 degrees. I would round that 8 up to a 9 since a 5 is after it. And of course, I forgot what it said. So 35.69 degrees. Okay, and then just as a side note, let's remember that in a right triangle, and any triangle actually, the three angles add up to 180 degrees. So since this angle, the right angle, is half of that, it's 90 degrees, and we know this one is about 35.69 degrees. Remember, you can always find that other angle by taking these away from 180. So when you take the 90 away, you're left with 90. So that means that let's call this angle X, 90 minus 35.69. And 90 minus 35.69 is 54.31. So you can actually find that other angle as well. And that concludes our review of finding missing angles in a right triangle.